30 years after its inception, the James Webb Space Telescope was launched from French Guiana on Christmas Day, 2 years ago. On December 28, it passed by the Moon, and on January 24, it fired its engines for 5 minutes before entering its final orbit, which was 1.15 million kilometers away from Earth. After months of tedious setup, it finally generated its first image on July 12 of last year, showing us distant galaxies for the first time as they appeared more than 13 billion years ago. Since then, the Webb telescope has continued to build upon this incredible foundation. It appears that the threshold has been lifted once more, and Webb is ushering in a new era of astronomy and space exploration. Its most recent photographs serve as proof of both humanity's capacity for discovery and its complete insignificance. Join us as we explore the new image captured by the James Webb Telescope that reveals the secrets of the universe. In actuality, telescopes are not physically peering back in time when they observe the light from distant galaxies. No one is able to directly gaze at the past because it no longer exists. Instead, the telescopes are observing a beam of light's current pattern. The beam of light has been essentially undisturbed for millions of years as it moves through the mostly empty vacuum of space. As a result, the pattern of this light beam at the present time is the same as the pattern it had when it was first produced by the far-off galaxy millions of years ago. We can therefore infer the galaxy's appearance millions of years ago by observing a beam of light in its current state. It's comparable to printing out a baby photo of your daughter and then looking at it 10 years later. You are metaphorically looking back in time when you look at the printed photo to see what your daughter looked like as a baby. However, you are not actually seeing back in time. Your daughter is not a baby anymore, and she doesn't have a baby self anywhere in the universe. Instead, you are viewing a current lighting pattern that was produced by the printed photograph's inks reflecting the light in the surrounding space. However, the current beam of light emanating from the picture has the same pattern as the beam of light that originated from your baby daughter 10 years ago because the ink in the picture has been specifically organized into a pattern resembling your daughter as a baby and because the ink pattern has not changed over the past 10 years. Imagine, for example, that some acid spills on the image, and a large white dot appears above your daughter's head. When gazing at the image, you would have to assume that your girl was being watched by a UFO or a ball of lightning 10 years ago if you were literally peering back in time. However, you're probably intelligent enough to know that you are not actually looking back in time, but rather at a current light pattern that no longer precisely resembles the pattern of light from when you shot the photo 10 years ago. Similar to this, we can only infer the past from present-day light beams hitting observatories directed at far-off galaxies if the light has not altered through time. A more accurate portrayal of the past would result from the light from distant galaxies changing as it travels, but this change would have to be in ways that humans can comprehend and subtract from. The redshift that results from the universe's expansion is one significant alteration to light as it passes across intergalactic space. Fortunately, since the redshift is now well understood, it is possible to shift the light pattern back by the proper amount to provide an accurate picture of the distant galaxy at the time the light was emitted. From just a few galaxies that were previously known to exist in that period, the James Webb Telescope, JWST, has now revealed hundreds of ancient galaxies that might be among the first inhabitants of the universe. According to a recent study, these very young galaxies displayed intricate structures and star formation clusters as early as 600 million years after the Big Bang. The study is a result of international cooperation known as the JWST Advanced Deep Extragalactic Survey, which collected data over the course of a month from two inconspicuous regions of the sky, one in the vicinity of the Fornax cluster and another in the constellation Ursa Minor. Over 700 recently discovered young galaxies in this area provide insight into the early universe. If you took the whole universe and shrunk it down to a 2-hour movie, you are seeing the first 5 minutes of the movie, Kevin Hain, an assistant research professor at the Steward Observatory in Arizona and a lead author of the new study, said while announcing the discovery. These are the galaxies that are beginning the process of creating the constituent parts and complexity of the modern world. The origins of the early galaxies and stars, which gave rise to the diverse range of elements seen in the universe today, are clarified by these recent discoveries. Using Webb's data, Hain and his team discovered 717 young galaxies in just those 5 minutes, which indicates that the universe is between 370 million and 650 million years old. These galaxies are all already thousands of light-years across, have intricate structures, and are giving birth to stars in numerous clusters. Previously, the earliest galaxies we could see just looked like little smudges, yet those smudges represent millions or even billions of stars at the beginning of the universe. Now we can see that some of them are actually extended objects with visible structures. Nearly all of the main space telescopes, including Hubble, the Chandra X-ray Observatory, and the now-retired Spitzer, have conducted substantial research on the 2 locations used in this study, collectively referred to as Good South. 93% of the newly discovered galaxies that Webb found during JADES had never been observed previously. Despite prior examination, only the brightest, most extreme instances of brilliant galaxies from the early cosmos were visible to us before. Now that the cosmos is still young and tumultuous, we are actually drilling down to more common, everyday galaxies. There's been much discussion on how exactly that chaotic, extremely dusty environment became the transparent universe we know today. One popular theory holds that this stage of the universe's evolution, known as the Epoch of Reionization, happened about 400,000 years after the Big Bang, when the first generation of stars, estimated to be 30 to 300 times as massive and millions of times brighter than our Sun, formed and illuminated the previously dark universe by dividing the cosmos's plentiful hydrogen atoms into protons and electrons. This ultraviolet starlight reionized the universe, a process that continued for 1 billion years after the Big Bang. Few researchers, however, believe that outflows from supermassive black holes, like the one in the center of our Milky Way, may have caused ultraviolet radiation from galaxies to escape and, as a result, may have had a more significant impact on cosmic development than previously assumed. Now, a second JWST team that has been researching galaxies between 500 and 850 million years after the Big Bang, or between 5 and 8 minutes of the 2-hour movie describing the universe, believes it has the solution to the age-old query. Albert Einstein's original prediction of gravitational lensing, which functions as a magnifying glass for astronomers, was made more than 100 years ago. The James Webb Space Telescope observed a massive cluster of galaxies, visible as they were when the universe was 4.6 billion years old, or just past the halfway point of the 2-hour movie of cosmic history. A galaxy lies between this cluster and Webb, which is one of the magnified very young galaxies we are observing due to gravitational lensing.